Sedef is one of our good friends, and she always is very kind to join us for events like this, even on very short notice. So thanks for doing that. So Sedef, for those of you who are less familiar with her, is an applied AI project manager at Vector Institute for Artificial Intelligence here in Toronto. She holds a PhD from a data science lab at Ryerson University in Canada, and has master's degrees both in engineering and in business administration. She's been working at Vector Institute at a very interesting capacity, which is an interface between Vector Institute and a lot of industrial clients where they do innovation projects. And since she has a lot of participation in sustainability, and part of her education was, or rather research was, in sustainability, she's going to tell us a little about that this evening. So Sedef, on to you.
Thanks, Amir. Hi, everyone. Happy to be here. And I'm not going to talk about a technical aspect of like a machine learning, how we contribute to the sustainability today. Instead, I'm going to step back and then look at the AI in the lens of sustainability, as Amir mentioned. So I've been doing sustainability research and sustainability design since 2011, since I started my PhD. So I would like to give you a brief information and how we can apply the sustainability design into the AI in general. So although like sustainability is not now, but it's been a major concern in society, there is a little understanding of how it's perceived by the AI professionals and how sustainability design can become an embedded part of AI or machine learning engineers. So we should think about every line of code has not just financial and technical implications, but also moral and ethical consequences as AI systems shape and inform human behavior. So as we know, in 1987, like a Brundtland Commission defines sustainability development as the meeting the needs of the present without compromising the ability of future generations to meet their own needs. The word here, need, is the center of this definition, includes a dimension of time, present and the future, as well as acknowledging the concept of changing stakeholders and changing requirements, and sustainability in generally defined as the capacity to endure, as we know. But in the context of AI, sustainability needs to be defined as the capacity of a socio-technical system to endure. So it can be, of course, argued that the controversy around how sustainability is defined is the result of how people think about a different perspective of systems and functions to be sustained over different time horizons by not explicitly declaring them in the discourse of designing a technological artifact. So to address this, it's been suggested that any actions referring to sustainability should answer these following questions. So what is to be sustained, for whom and for how long? It could be short term, it could be long term, it could be a decade or three. So, and at what cost? What is the ROI for this? So a few years ago, me and my international research collaborators released a Karlskrona Manifesto for Sustainability Design, providing a focal point for establishing a common ground for systems by advocating a set of fundamental principles and commitments that underpin sustainability design. So the principles that we advocated stress the importance of recognizing that the sustainability is an explicit consideration, even if the primary focus of the system that you're designing is not sustainability. So we also advocate that the sustainability must be viewed as a construct across 5 dimensions: environmental, economic, individual, social, and technical, and considers the potential immediate impact, long-term effect, and systemic effect of the systems. So this is also as the triple bottom line effect. So let me quickly explain what these dimensions are. So the individual dimension covers the individual freedom and agency, like human dignity and fulfillment. It includes individuals' ability to thrive, exercise their rights, and develop freely. So looking at the social dimension, it covers the relationship between the individuals and groups. It covers the structures of mutual trust and communication in social systems and the balance between conflicted interests. The economic dimension, it covers the financial aspect and business values. So it includes like capital growth, in liquidity and investment questions and financial operations. And the technical dimension covers the ability to maintain and evolve artificial systems over time. So it refers to maintenance and evolution, resilience, and the ease of system transitions. And the last but not least, environmental dimension, it covers the use and stewardship of the natural resources, ranging from immediate waste production and energy consumption to balance of local ecosystem and climate change concerns. Next slide, please. Recently, I co-developed sustainability awareness framework with my international research collaborators using design science. It is a rigorous process of designing artifacts to solve problems, to evaluate what was designed or what is working, and to communicate the results with stakeholders. The main goal of the framework is to raise awareness of the sustainability effect that a software-intensive system, or in general any systems, could have in its intended context. So the diagram you can see on the left side is a visualization tool which breaks down graph into 5 interrelated dimensions, as I mentioned earlier, of the sustainability. And each dimension is further divided into 3 orders effects. So these are, as I said earlier, immediate effect caused by the direct function of the system or its development. The second order, which is enabling effect, it arising from the application of the system over time. Or structural effect, for example, it refers to the persistence of changes that can be observed at the macro level. So these are the illustrations, starting with immediate effect in the center, the enabling effect in the middle, and then the structural at the external layer of the diagram. So let me exemplify the use of this diagram, having the example of an Airbnb system. So Airbnb offers a peer-to-peer short-term accommodation booking platform. So it allows property owners to rent out their homes or rooms as an enabling technical effect. As a result of persistent rental using Airbnb, homeowners, say, for example, earn 50% more than the median on long-term renting, which is an enabling effect upon individuals. And increased median and long-term rent due to reduced long-term rental accommodation stock is a structural economic effect of this platform. Finally, the gentrification of the primarily non-white localities and increased race separation is its structural social impact. So there may be several questions asked about the relationship between AI and sustainability. For example, the sustainability of AI, how AI evolves, or the impact of the AI on society in terms of generations or in terms of the needs. So the sustainability analysis that sustainability framework that I just explained to you, that was applied recently on the field of AI using the lens of 5 dimensions. So let me illustrate this analysis using sustainability framework, the one on the right side of the slide. So if you look at the economic level, AI is already a major industry, and governments of countries with advanced economies and the large technology companies, they are investing in the implementation of the solutions, and it creates a competitive advantage. First, say, for example, such investment give a competitive advantage at the national level for advanced economies. However, they also have a negative impact on the globalization of the production and services, which means that in the current scenario, companies from, let's say, advanced economies outsource services, for example, like call centers and manufacturers to emerging nations due to cost advantages. However, some of the companies that maximizes AI's capabilities will no longer have to worry about paying outsourcing costs and living wages. So if the companies from advanced economies bring their development back into house, there may be a disruption in local businesses and the job markets of emerging economies. It may result in a rise of unemployment and decrease in the individual's spending power. So if we look at the technological level, AI may learn and teach how to code itself that can cause the disruption towards the IT industry. The impact of this development is hard to foresee, but it will increase the speed of research and development, of course, we've seen now. In terms of the a positive impact, it may have, we can expect more like a capable systems that can take over more complex tasks. In terms of the negative impact, we can perceive the necessity of stronger engineering ethics as more and more responsibilities are placed into the like a hands-on developers who could engineer the system upfront and therefore must foresee many wanted or unwanted usage of scenarios. So this is a much greater and prematurely accumulated responsibility than a machine, let's say, operator would perceive when like handling a machine every day and making individual situation specific decisions based on the expertise and years of experience in the field. So when we look at the environmental level, AI can impact waste and pollution management, and it can also negatively impact sustainability in form of the power and resource consumption. It may be useful in helping us take better care of the planet in terms of supporting the waste or pollution management, as I said, but also predictive system can be used for like earthquakes and weather forecasting to better recognize the likelihood of extreme event occurrence, such as like hurricanes or tsunamis. It can also be used for better pollution management. And additionally, like adoption of autonomous vehicles, this could be a possible turning point for reducing the greenhouse gas emission. The increase of production and consumption of the technological devices that will have negative effect, and then use of the computers and the powers and the resource consumption, it will also create a negative impact on sustainability. So if you look at the individual level, AI may impact work, empower user with agents, and affect interactions or social isolation. So since AI systems are artifacts, they are constructed by the people to fulfill their own goals, interest, and like a personal characteristic, and to make the machines more intelligent for some form of prediction using various inputs, such as like cameras and text and gestures and like audio and analysis of neural networks. And a company could collect the data without an individual's knowledge or consent. So these kind of issues raise question on how much privacy individuals really have in the area of the AI, and when the data are collected intentionally or unintentionally. So this will also require the change in like maybe the education, or which will also be part of this individual sustainability. And then finally, the social level, AI can take a role in assisting in communities, like managing social media or automating the routine tasks that are commonly outsourced, and participating in like a digital storytelling. And we can see some benefits as well as the challenges in this case. So there is the chance to strengthening the communities, but also a requirement to develop legal framework around AI. So considering all these 5 dimensions, it seems that the peculiar that the main outcome of our sustainability analysis is that AI can have positive and negative impact on all 5 dimensions. And then again, that makes sense because it means that not we have to look at all the dimensions as if we would like to consider the sustainability as a whole. And then next slide, please. So to conclude my talk, so one can see that the value, collaboration, sharing the responsibilities, and ethics are important measures that we should take into consideration. Not only we, but also like all stakeholders who are impacted by the systems or they're impacted to the system. And if these measures are taken into consideration, there is a possibility that no matter how clever or like artificial intelligent computers get, and no matter how much they help us advance our lives, they will always be strictly machines, and we will be strictly humans. So this presented sustainability analysis diagram can be used as a tool to understand both the positive and negative impact of the AI system on the 5 dimensions of sustainability. So for the future, we need to have more in-depth sustainability analysis for several application domains of AI. So whereas an analysis of the 3-order effects, like the life cycle, enabling, and the structural, those should be included in those analyses. So in terms of ethics and transparency of these systems, there should be a interdisciplinary approach should be taken, and then we need to perform joint effort by having behavioral psychologists or philosophers of computer scientists. So they need to work together in order to have this kind of analysis together. And the third point is the responsibility and accountability for those systems. So we need to have a qualitative analysis on how much citizens are willing to give up their freedom of choice and have these kind of systems take somewhat optimized decisions for them. So how much operators are willing to pass on their responsibility to this kind of systems, and how much developers are willing to be accountable in the case of something fails, or along with how to allow for and ensure transparency. So those needs to be considered. And last but not least, the perception of AI. So a large-scale analysis, again, should be conducted on individual perceptions in diverse stakeholders and their roles towards having an AI integrated in society on several levels of technological interventions. And next slide, please. So if you are interested and you would like to learn more about this Cascona Manifesto for Sustainability Design, and if you'd like to get involved or collaborate, you can contact with us. And here's our website, sustainabilitydesign.org.
Thank you so much, Sedef.